So hello friends, I welcome you again in this backbenchers class. So today I have taken the question from 2005 Engineering Services Examination, which says a Pelton turbine is to work at the foot of a dam whose reservoir level is 220 meter. The head at the full opening of the turbine nozzle is 200 meter, and the coefficient of velocity is 0.98. The turbine is to operate at 200 rpm and develop a power of 3.7 megawatt. Assuming the blade to jet speed ratio as 0.46, estimate the wheel diameter. If the blade outlet angle is 16 degree, determine the blade and hydraulic efficiencies. Neglect any friction loss. So before attempting the solution of this question, let us discuss how Pelton turbine works. The Pelton turbine consists of basically a dam and a penstock and a nozzle and the Pelton wheel, which has a semi-ellipsoid shape of the cup at the periphery of the wheel. So, dam store the water at a high head, and then this water travels to the penstock at penstock end, and after the end of the penstock, there is a nozzle which converts the head of the water into a hydraulic kinetic energy of the jet. So, kinetic energy of jet. So, after jet impinges on the semi-ellipsoid cup of the Pelton wheel, it the transfer of momentum take place, and eventually it rotates. So the head available at the dam is called gross head, and the head available at the penstock end is called net head, which is going to be convert into power. So how this works? So here is a reservoir, and then there is a friction loss of water, frictional loss of head until the penstock ends, and then is a head loss in the nozzle, and then after nozzle, water goes to turbine. Before turbine, it can have a hydraulic loss, blade friction loss, eddy formation, energy content of water leaving, and leakage loss. These are the losses which occurs after the nozzle. And then when the turbine rotates, the power transmitted to the shaft. Through shaft, it has a mechanical loss like loss of bearing, loss associated with the bearing. And then where the final power generation take place at the generator, there is some kind of generator loss. So this is the basic idea how water travels in a Pelton turbine. So now let us discuss the solution of this question. So let us first write down the data given in the question. So let us calculate the spouting velocity. Spouting velocity equal to root 2 gh into 9.81 into 200, which equals 62.64 meter per second. Now let us calculate the actual velocity. Actual velocity CV times root 2 gh. Q is given. We have Ku is equal to U divided by root 2 gh. So speed ratio is the ratio of blade velocity to the spouting velocity. Now let us calculate the blade velocity because other three and two quantities are known. So we got the blade velocity is 28.81 meter per second, and we also know that blade velocity is equal to pi dn by 60. So in this equation only d is not known, so we will find the diameter of the wheel by putting the values. So diameter of the wheel is 2.75 meters. Now we will go to the second part of the question, which says the blade efficiency and hydraulic efficiency. So blade efficiency is the power generated by the blade to the power input of the blade or kinetic energy of the jet. To calculate power generated by the blade, let us draw the blade velocity diagram. And now let us calculate the power developed by the blade. So it will be equal to momentum, change in momentum of the blade. So since we have drawn the velocity diagram of the blade, now let us calculate the power generated by the blade. So power generated by the blade will be equal to rho Q VW1 plus minus VW2 into U, where VW1 and VW2 are the tangential component of the velocity. So Pelton turbine, the tangential component of the velocity at inlet is equal to the actual velocity of the jet. So we have VW1 is equal to V1. To calculate the tangential component of the velocity at exit, since there is no frictional loss over the blade, the VR1, the relative velocity of jet at inlet, is equal to the relative velocity of jet at outlet. So we have VR1 is equal to VR2. Since VR1 is equal to V1 minus U from the inlet diagram, we can see that. So to calculate VW2, we have VR2 cos phi, VW2 is equal to VR2 cos phi minus U. Putting the value of VR2, we get V1 minus U cos phi minus U. Let us name this equation as number 1 and this equation as number 2. Putting value of 1, putting value from equation 1 and 2 in the equation A. So we have power is equal to W is equal to rho Q V1. Now let us decide that positive or negative sign will be considered since the direction of the jet is opposite to the inlet. The direction at the exit of the blade is opposite to the direction at the entry of the blade. So it will be add. It will be added. So V1 plus V1 minus U cos phi minus U. Now rearranging the term of W, we get rho Q V1 minus U 1 plus cos phi. This is the power generated by the blade. So to calculate the blade efficiency, we get NB is equal to rho Q V1 minus U 1 plus cos phi divided by half into rho Q V1 square. Now cancelling the term, rho Q cancel, and it will be 2 V1 minus U divided by 1 plus cos phi upon V1 square. Let us put the values. So 2 into V1 we have calculated. V1 we have calculated 61.38, 61.38, and U is 28.81. 1 plus cos phi is 16, cos 16 divided by 61.38 whole square. So blade efficiency will be, so the blade efficiency is 97.69%. Now we have to calculate the hydraulic efficiency NH, which is equal to power generated by the blade divided by head supplied at the turbine inlet. At the turbine inlet. So let us calculate rho Q V1 minus U 1 plus cos phi into U divided by rho Q GH. So rho Q cancel. V1 is 61.38 minus 28.81 1 plus cos 16 into 28.81 divided by G into 200. So NH comes out. So the hydraulic efficiency is 93.79%. So what we have learned from this question that uh, it is given this one is irrelevant data, this one is also irrelevant. Only other data is important. So we have solved this question. Now let us move to the next question. If you have any doubt, please join the Telegram channel and ask me there. I will answer you. I will try to answer your query. The second question, which we are going to solve, it is from 2009 Engineering Services Examination. So this question says a three-jet Pelton turbine is required to generate 10,000 kilowatt under a net head of 400 meter. The blade angle at the outlet is 15 degree and the decrease in relative velocity while passing over the blade is 5%. And determine the diameter of the jet, the force exerted by a jet on the buckets, and then overall efficiency given, coefficient of velocity given, speed ratio given. Further, if jet ratio is not to be less than 10, calculate speed of the wheel for a frequency of 50 Hz and corresponding wheel diameter. Okay, so let us begin the solution of this question. First, we will write down the given quantities of the question separately. So we have written down the quantities and also the quantities which are to be determined. Now we know that overall efficiency of the turbine is given by power. Now we know that overall efficiency is given by power output divided by power supplied. Since overall efficiency given and power output is given, so from power supplied we can calculate the discharge. Putting value of rho, G and H, we can calculate Q. So Q is equal to 10 to the power 7 divided by 0.8 into 10 to the power 3 into the density of water is 10 to the power 3 kg per meter cube. Then 9.81 and the net head. Head is given how much? Head is given 400 meters. So Q is equal to, so we have calculated discharge which is equal to 3.185 meter cube per second. Now in the question it is said that there are three jets. So the discharge from each jet can be calculated by Q divided by Q by N is equal to 3.185 divided by 3. It will be equal to 1.0618 meter cube per second. To calculate the diameter of jet, we can use Q is equal to pi by 4 d square into V1. So 1.0618 is equal to pi by 4 into d square into CV root 2GH. So d is equal to 1.0618 into 4 divided by pi into 0.98 into under root 2 into 9.81 into 400. So d is equal to 0.124 meter or 124 mm. So to calculate force by the jet, we will calculate actual velocity and we will draw the velocity triangle of the blade. So the actual velocity is 86.81 meter per second. Now we will calculate the blade velocity. So since the speed ratio is given, we will use that to find the blade velocity. So here we write Ku is equal to u divided by spouting velocity, that is 2 root 2 g h. So here all other things are known. So we can find out u. U is equal to ku root 2 g h. So finally u comes out. Now we will calculate relative velocity at inlet, which will be Vr1 is equal to V1 minus U, that is 86.81 minus 40.75. So Vr1 is equal to 46.06 meter per second. As it is given that 5% of this velocity is lost till the jet is exiting from the blade. So exit relative velocity of jet at the exit, that is Vr2 is equal to 95% of Vr1, 95% of 46.06 is equal to, so that will be equal to 43.75 meter per second. Now we will make the velocity triangle. So suppose this is our semi-ellipsoid cup. So here we have made the velocity triangle for this Pelton turbine. Now we will calculate the tangential component of velocity at entry is equal to the actual velocity of jet. So V1 is equal to VW1. And at the exit, the tangential component of exit velocity is equal to Vr2 cos phi minus u. So putting the value of Vr2 and u, we will find the Vw2. So Vw2 is 1.51 meter per second. Now the force exerted by the jet, by each jet on the wheel, can be calculated by Fj is equal to rho into q. Here q is taken for each jet, rho q Vw1 plus Vw2. So we have 10 to the power 3 into q is 1.0618. Q is 1.0618 into V1. V1 we have calculated 86.81. 86.81 plus 1.51. So it will be equal to, so Fj is equal to 93.707 kilo. This is for each jet. Now we will go to the other part. To calculate the diameter of the wheel, it is given that jet ratio. What is jet ratio? Jet ratio M is equal to diameter of wheel divided by diameter of jet, which is to be greater than 10. So what we will do, we will calculate the D taking the basic value 10. So D is equal to 10 into 0.124, 0.124, which is equal to 1.24 meter. So since u is known, we can calculate the n RPM of the wheel as equal to n is equal to 60 into u divided by pi into g. So 60 into 40.75, 40.75 divided by pi into 1.24. Then n is equal to, so n is equal to 627.63 RPM. We have for constant frequency f is equal to Pn divided by 60, where P is number of poles and N is RPM of wheel. So since P is not given, we will calculate N by taking any arbitrary value of P. So let us take the value of P 5, so that N is equal to F into 60 divided by P. 60 into 60 divided by 5 comes out to be 600 rpm. For this rpm, the diameter of the wheel is equal to 60 into 4.75 divided by pi into 600. D is equal to, then D will be 1.29 meters. Then the jet ratio will be D by D, which is equal to 1.29 divided by 0.124. So the exact jet ratio is 10.4. So this is the solution of this question. Now I have attached the homework question at last. So you can attempt that question and share your solution in the Telegram group.